Imagine there are entire worlds in our solar system that we've never seen. That right now, while you're watching this, something the size of a small country is quietly orbiting far out beyond Neptune, in a place so remote that sunlight is barely more than a rumor. What if something about these worlds could completely upend what we think we know about our own cosmic neighborhood? Today, we're about to dive into a discovery that might redraw the map of our solar system and reignite a decades-old mystery that has obsessed astronomers and science fiction fans alike. Is there a hidden planet, or maybe even a lost population of worlds, lurking at the edge of our sun's reach? This isn't a story about distant galaxies or black holes millions of light years away. This story is about our own backyard and the secrets we've barely begun to uncover. Welcome to the outer solar system, where cold, darkness, and mystery reign. For most people, the map of our solar system is simple. Mercury, Venus, Earth, Mars, the rocky worlds close to the sun, then the gas giants, Jupiter and Saturn, the ice giants, Uranus and Neptune, and, somewhere beyond, a fuzzy region called the Kuiper Belt, home to Pluto, the planet that was, then wasn't, and now sits in celestial limbo as a dwarf planet. Conventional wisdom has long said that after Neptune, the solar system essentially peters out, with just a handful of icy debris and cosmic leftovers drifting aimlessly in the dark. But in the past 2 decades, this idea has been flipped on its head. Astronomers have found a growing menagerie of distant objects orbiting well beyond Neptune: Eris, Makemake, Haumea, and now, a new candidate that could be among the most extreme yet, known only by its cryptic name, 2017 OF201. What is it? Why does it matter? And what could its strange journey through the dark teach us about the solar system's hidden architecture? Let's take a crash course in the real Wild West of the solar system. The Kuiper Belt, a donut-shaped ring of icy bodies that stretches from the orbit of Neptune out to about 50 astronomical units from the Sun. That's 50 times farther from the Sun than Earth is. In this cold, dim region, Pluto and its sibling dwarf planets wander among thousands, possibly millions, of smaller objects. But here's the jaw-dropping part. We've only scratched the surface. Of the potential hundreds of thousands, maybe millions, of these Kuiper Belt objects, we've detected just over 2,000. The rest are simply too distant, too dim, or too small for even our best telescopes to spot, at least so far. And these aren't just random space rocks. The Kuiper Belt is a time capsule, a frozen record of the solar system's ancient past. Many of its residents are relics from the earliest days of planetary formation, their orbits and compositions holding clues to how everything, from Jupiter to Earth, came to be. There are different kinds of inhabitants in this cosmic frontier. Astronomers sort them into classes. Classical Kuiper Belt objects, which follow neat, orderly orbits. Resonant objects like Pluto, which are locked in gravitational dances with Neptune. And then there are the so-called scattered disk objects, whose orbits have been stretched and twisted by the mighty gravity of the giant planets, sometimes sending them on paths that carry them tens or even hundreds of times farther from the Sun than Pluto ever travels. Now let's return to that cryptic new arrival, 2017 OF201. This isn't just another icy pebble. With an estimated diameter of about 700 kilometers, nearly 1/3 the size of Pluto, it would rank as the second largest known object in such a distant orbit. But what really sets it apart is its mind-bending orbital path. At its closest, it's already 44 times farther from the Sun than Earth, a bit beyond Pluto's average distance. But at its farthest, it ventures some 1,600 times farther out. To put that in perspective, New Horizons, the fastest spacecraft we've ever launched, would need more than 3,000 years just to make a single flyby at that distance. It takes OF201 an estimated 25,000 years to complete a single elongated orbit. It spends most of that time in the deep freeze, so far away that it escapes detection by even our most powerful telescopes. Only during a narrow 1% of its journey does it come close enough for our technology to spot it. That's how lucky we were to catch a glimpse at all. Here's where it gets even stranger. Its orbit doesn't cluster with other extreme trans-Neptunian objects, TNOs, a group whose mysterious, similar alignments have fueled the Planet 9 hypothesis for years. More on that in a moment. Instead, 2017 OF201 seems to be an outlier, breaking the pattern that's been one of the biggest clues in the search for a massive, unseen planet out there in the dark. Jacksuan Lee, a Princeton astrophysicist and co-discoverer, puts it bluntly. This object is an outlier. Its orbit doesn't quite fit the pattern used to support the idea of an undiscovered planet. That's a shot across the bow of one of the most tantalizing theories in modern astronomy, the hunt for Planet 9, or Planet X, a hypothetical world perhaps 10 times the mass of Earth, shepherding distant objects into strange alignments by its gravity alone. Finding 2017 OF201 wasn't easy. We found it by combing through years of archival images, looking for tiny moving points among literally billions of stars, says Sahao Cheng from the Institute for Advanced Study. It required not just sharp eyes but powerful new algorithms, like those developed by Lee, to pull this frigid wanderer out of the cosmic haystack. The discovery data came from facilities like the Victor M. Blanco telescope and the Canada-France-Hawaii telescope, as well as records from the Dark Energy Camera Legacy Survey. It's a testament to the power of open science. Nearly anyone with the data, the tools, and the patience could have found it. Here's an emotional reality check. If 2017 OF201 spends only 1% of its entire orbital journey within our detection range, and we just happen to catch it at the right moment, how many more worlds are still out there, wandering the far reaches of the solar system, completely invisible to us? Sahao Cheng estimates there could be another 100 or so other objects with similar orbit and size. They are just too far away to be detectable now. Think about what that means. Our own solar system might be teeming with hidden worlds, a cosmic archipelago more vast and mysterious than we ever imagined. But this discovery also raises tough questions. The orbit of 2017 OF201 is so stretched that it ventures deep into what astronomers call the inner Oort cloud, the hazy borderlands between the Kuiper Belt and the even more remote Oort cloud, a hypothetical shell of icy bodies that may surround the entire solar system like a distant halo. Its sheer eccentricity, how elongated the path is, suggests it might have been launched to these outer reaches by a violent gravitational encounter, possibly with one of the solar system's giant planets. Could this be evidence for an ancient game of cosmic billiards, with Jupiter or Neptune slinging smaller worlds into exile? But if its odd orbit doesn't fit with the TNOs that seem to point toward Planet 9, does this undermine the case for a ninth major planet, or does it hint that our models are still missing crucial pieces? Here's where the plot thickens. The so-called Planet 9 was first proposed to explain a mysterious clustering of orbits among certain distant TNOs, whose paths all seem to point in the same direction, almost as if an invisible giant planet was corralling them with its gravity. Computer simulations suggested that if a planet, perhaps 10 times the mass of Earth, were lurking 600 to 1,000 times farther from the Sun than Earth, it could explain these alignments. The scientific and pop culture appeal was irresistible. A hidden planet in our own solar system became the stuff of headlines, speculation, and dreams. But 2017 OF201 complicates this narrative. Its orbit doesn't cluster with the other candidates' orientations. In fact, if Planet 9 really existed, simulations suggest its gravity would destabilize OF201's path so severely that it might be ejected from the solar system entirely within just 100 million years, a cosmic blink of an eye compared to its vast orbital period. I don't think this planet would have any of the effects on the solar system that we think we're seeing, says Mike Brown of Caltech, one of the original proponents of the Planet 9 hypothesis. That's not to say the case is closed. As Konstantin Batygin, a leading theorist, points out, there are a number of distinctive orbital signatures that point to the existence of Planet 9, but we need more data to confirm its presence. And Meg Schwamm of the Gemini Observatory stresses, discovering objects like 2017 OF201 helps us to understand the diverse populations that exist in the outer solar system and how they came to be. What's truly staggering is how much we simply don't know. Even with revolutionary missions like New Horizons, the probe that gave us our first close-ups of Pluto and Arrokoth, we're still working with the faintest of signals, the barest hints of what's really out there. The outer solar system is wildly dynamic, prone to chaos, and full of surprises. Scott Shepard of the Carnegie Institution for Science captures it perfectly. The outer solar system is a very dynamic place, and small objects can be easily perturbed by the gravity of the giant planets. Here's an emotional moment. Imagine, in the year 1930, the world celebrated the discovery of Pluto. Little did we know that, at that very time, OF201 was making a rare close approach to the Sun, its perihelion, the point in its orbit closest to us, before slipping back into the inky darkness for thousands of years. It was right there, hiding in plain sight, unnoticed as humanity's telescopes cheered another discovery. So what's the main conflict? It runs deeper than just identifying one more distant object. Instead, it exposes the profound limits of our knowledge. Our models for how the solar system is structured, for how planetary giants shape their lesser siblings, are under fresh assault. The discovery of OF201 could indicate that the outer solar system is even more chaotic and populated than we dared imagine. It throws cold water on some theories, while fanning the flames of others. Is there a secret ninth planet, or are we chasing shadows cast by the statistical quirks of a tiny, biased sample? Are worlds like OF201 refugees from violent pasts, scattered by planetary encounters? Or are there new rules of celestial mechanics waiting to be discovered in the cosmic dark? The race is on. New telescopes like the Vera C. Rubin Observatory are set to come online, promising to widen our cosmic fishing net and perhaps double or triple the number of known distant objects. But every new discovery brings new complications and new paradoxes. What other secrets are waiting out there, just beyond the reach of our technology? What risks and opportunities for science, finance, and even future exploration emerge when we realize our map is incomplete? And the most tantalizing question of all, what or who will rewrite the next chapter in the story of the solar system's edge? As we stand on this threshold, peering into the deep, dark unknown, we're forced to confront a humbling possibility. The most profound discoveries may still be waiting, just beyond the light. If part 1 left you feeling as though the solar system just got a lot bigger and a whole lot stranger, buckle up, because we're about to journey even deeper into the unknown. The discovery of 2017 OF201 leaves us at a scientific crossroads, with new mysteries beckoning from the farthest corners of our celestial neighborhood. Let's talk about what comes next. The intrigue of 2017 OF201 isn't limited to its lonely trek through the outer solar system. Instead, it opens a new chapter in humanity's quest to map the edges of our cosmic home. The object's orbit, which stretches up to 1,600 times farther from the Sun than Earth, hints that our solar system's boundary is less a wall and more a vast, shifting frontier, a place where our neat models unravel and new questions emerge. First, imagine the risks and opportunities hidden out there. If 2017 OF201 is just the tip of a dark cosmic iceberg, one out of potentially hundreds or even thousands of such worlds, our current models of planetary formation and migration will need a major update. Hao Cheng, one of the astronomers leading this research, put it best. The presence of this single object suggests that there could be another 100 or so other objects with similar orbit and size. They are just too far away to be detectable now. Think about that for a moment. Every faint detection could represent an entire class of undiscovered neighbors, some the size of mountains, others as massive as Pluto. Some might even be large enough to challenge what we define as a planet. Suddenly, the solar system seems teeming with hidden potential. Each new discovery a possible window into ancient times, when the sun was young and swirling clouds of gas and ice shaped everything we see today. This explosion of unknowns has direct consequences. The most obvious is the debate about Planet 9, the hypothetical world thought to lurk at the outer edge of the solar system, shepherding clusters of distant objects with its gravity. Some researchers have argued that the peculiar orbits of far-flung TNOs are evidence for this massive, unseen planet. But 2017 OF201 throws a wrench into that theory. Its orbit doesn't match the patterns expected if Planet 9 exists. Jiaxuan Li, a Princeton astronomer who helped find the object, calls it an outlier. If more objects like 2017 OF201 are found, and if their orbits are equally odd, we may have to rethink the entire Planet 9 hypothesis. Or it could mean the architecture of our solar system's outskirts is even more complicated, shaped by ancient gravitational skirmishes, wandering stars, or even close brushes with other solar systems eons ago. But let's not stop at theoretical debates. The future of this research lies in both technological breakthroughs and human curiosity. Right now, objects like 2017 OF201 are detectable for only about 1% of their enormous orbits. Most slip by in the darkness, undetected by even our most powerful telescopes. But upcoming observatories like the Vera C. Rubin Observatory are about to change that. With its vast, sensitive eye, Rubin could find dozens, maybe hundreds, more distant worlds in just a few years. The pace of discovery is about to accelerate dramatically. As we chart more TNOs, we'll get a much clearer picture of the solar system's architecture. We might finally answer whether Planet 9 is real, or if something even stranger is at work. Each new object could provide a crucial data point, sharpening the debate and focusing the search. And that's not all. There are real practical stakes involved. These distant objects are more than astronomical curiosities. They are time capsules from the solar system's earliest days. Their orbits, surfaces, and chemical makeups preserve information about an era otherwise lost to history. By studying them, we peer billions of years into the past, glimpsing the processes that shaped not just our solar system, but possibly others beyond it. Imagine the possibilities. Missions inspired by discoveries like 2017 OF 201 could one day target these objects directly, much as the New Horizons mission did with Pluto and Arrokoth. Of course, such missions are technologically challenging. The distances are staggering, communications slow, and the conditions harsh. It might take decades to reach even the closest of these objects. Yet the potential payoffs, clues about organic molecules, the history of water ice, or even the processes that form planets, could reshape our view of the cosmos entirely. But the benefits aren't just for scientists. Here's where it gets personal. What does all this mean for you? Why should you care about a frozen world billions of kilometers away, looping through the dark? First, it's a powerful reminder that the universe is so much bigger, weirder, and more full of surprises than we often realize. Scientific discovery is not a closed book. Every breakthrough, like the sighting of 2017 OF 201, teaches us humility, reminding us that there's always more to learn. The night sky isn't just a static backdrop. It's alive with motion, with stories unfolding that we're just beginning to read. Second, the methods used to find 2017 OF 201, algorithmic breakthroughs, the clever use of archival data, and the democratization of scientific tools, demonstrate how open science is changing the world. Anyone with access to data and the right analytical skills has the chance to uncover the next great secret. It's an invitation. You don't have to be at a giant telescope or in a world-famous lab to make a difference. Sometimes all you need is curiosity, perseverance, and a laptop. Third, this discovery is a vivid example of how scientific progress happens on the frontier. Things we haven't even imagined yet might be out there, waiting for a careful observer or an innovative thinker to spot something odd in the data. It rewards creativity. The next 2017 OF 201 could be hiding in plain sight right now. Imagine the broader lesson. We often think we've already mapped all the big mysteries, that the most exciting discoveries are behind us. But the universe keeps proving us wrong. Whether it's our solar system or our individual lives, much remains unexplored, waiting to be noticed, questioned, and understood. That's a mindset worth carrying into your own fields. Never assume you've seen all there is to see. All of this brings us to a profound conclusion. The discovery of 2017 OF 201 isn't just a footnote in the history of astronomy, it's a turning point. It forces us to question our assumptions about what's out there and how we search for it. It tells us that, no matter how confident we feel about our models, the universe is always ready to surprise us. Returning to the main question, how will 2017 OF 201 reshape our understanding of the solar system, and what will future observations reveal? The answer is, in profound and unpredictable ways. This single detection is causing astronomers to re-examine the dynamics of the solar system's edge. Is Planet 9 real, or just a mirage conjured by incomplete data? Are ancient ejection events, from planetary migrations or cosmic near misses, more important than we thought? Could there even be objects from outside our solar system hiding out there, masquerading as TNOs? And as new telescopes scan the sky, the chances of finding even more bizarre worlds skyrocket. Each new discovery will bring fresh puzzles, giving us a much richer, more complicated, and beautiful story of our own cosmic backyard. Here's the secret many people don't know. The outer solar system is so unexplored that even today's high school students, amateur astronomers, or data enthusiasts could find the next 2017 OF 201. The data is out there, waiting. Open science means the door is open for all. In the words of Meg Schwamm from the Gemini Observatory, discovering objects like 2017 OF 201 helps us to understand the diverse populations that exist in the outer solar system and how they came to be. So what can you do? Stay curious. Follow new discoveries. Don't let the unknown scare you. Let it inspire you. Try learning more about astronomy or data science. If you have a passion for stargazing or exploring the archives, dig into projects like the Zooniverse, where citizen scientists help scan for new solar system objects. Who knows? Your name might one day be attached to the next dwarf planet. And of course, keep asking big questions. The edge of the solar system isn't just a physical place. It's a symbol of all the frontiers left to explore. Every time a new world appears out of the darkness, it's an invitation. Keep pushing, keep wondering, and keep searching. Because as we've just seen, the greatest mysteries may still be waiting, right on our cosmic doorstep. If you enjoyed this journey to the edge of the solar system, smash that like button, subscribe for more deep dives into space's biggest secrets, and let us know in the comments what you think we'll find next. Want to learn more about open science or help identify new objects? Check the links